Hello, this is Hui. Welcome to watch my video, C++ programming on Linux. In previous video, it has introduced Libusb, a cross-platform and open-source user library that allow you to communicate with USB devices from user space. In this short video, it will discuss how Libusb Hotplug event notification works. Libusb device Hotplug event notification feature. Since version 1.0.16, Libusb has added support for Hotplug events on some platforms. You should test if your platform supports Hotplug notification by calling function libusb has capability with the parameter libusb cap has Hotplug. There are two supported Hotplug events. Libusb Hotplug event device arrival. A device has arrived and is ready for use. Libusb Hotplug event device left. A device has left and is no longer available. A Hotplug event can listen for the either or both of these events. The example of this short video is going to write a C++ program, demonstrate basic Libusb Hotplug event notification features. Now we write a program named libusb hotplug.cpp. This program is used to detect Hotplug USB attach, detach event and display the device information. The usage will be no argument, and for write Libusb API, it first have to initialize Libusb, at end deinitialize Libusb. Any logic and using Libusb function has to be between Libusb init context and Libusb exit. After initialize Libusb, first step we have to check if our platform support Hotplug using function Libusb has capability. We are going to check if the Libusb cap has Hotplugs. If this function returns 0, it means our platform doesn't have this capability. So we print off notification. Otherwise, print out. Next step, we are going to register USB attach event callback using function libusb hotplug register callback with the event libusb hotplug event device arrive. Function libusb hotplug register callback register a hotplug callback functions. This function takes 9 parameters. First parameter is the context ctx. Second parameter is event. There are two types of event: Hotplug device arrive and device left. Third one is the flag. Next three, vendor ID, production ID, and the device class will be hot callback matching the devices. Next is the callback function. User date is the parameter, pass the callback function, and the last one is the callback function handles. Back to our editor. We declare callback function handle, attach handle, vendor ID, product ID, class ID, In our example, we're using the Libusb Hotplug MyTraining. First parameter is context. We're using default context, none. Second parameter will be the event, which is the Libusb Hotplug event device arrive. Next is Hotplug flag. We'll put no flags. Next is vendor ID, product ID, class ID. Next is the callback function. Hotplug callback attach. Parameter passed to the callback function is none, and pointer of attach handle. Return code not equal. Libusb success. If error, print out the message error register attach callback. When success, next step, register event left callback, which is unplugged callback. We copy this 13 line, 13 YY. We paste here. Delete this. Detach handle and event will be device left. Callback function will be Hotplug callback detach, and the handle will be the detach. If error, we just print out register detach callback error. Function is register callback detach. After success, print out registered event detach callback. Next, start listening Hotplug USB device to attach and detach event. First, we print in this demo, we just handle two events, an event attach and an event detach. For make a programmer simple, we just declare an integer variable called event count. Event count less than 2, it means 2 events not completed. Function Libusb handle events, listening the event coming. Libusb has a few handle event function. Libusb handle events, Libusb handle events completed, Libusb handle event logged, handle event timeout, handle event timeout completed. In our demo, we using Libusb handle events. Function Libusb handle events handle any pending events in blocking model. This function take one parameter, context. We are using non-default context. This function returns 0 on success or Libusb error code on the failure. Back to our editor. If return code not equal Libusb success, print out error message. There's a typing error here. We're using this event count tool just for keep our demo example simple. This might be not the perfect logic. Step 5. Deregister Hotplug callback. Function Libusb Hotplug deregister callback. First parameter is a context. We use none. The second parameter is the handle. detach handle. Next will be exit and return program success. Next, we're going to write two callback functions. First is a Hotplug callback attach. In this function, first parameter will be the context, second parameter will be the device, third parameter will be the event, and the last parameter, user date, which is the parameter we pass to this function. This function will be triggered when the USB device has been attached to the US port or plugged in, and we're going to print out Hotplug function has been fired, and the event count +1, then print the device info. For the function Hotplug callback detach, same as attach callback, we're going to print out Hotplug callback detach has been invoked and the event count +1. After that, we're going to get a device descriptor and display info which device has been detached. If this device is open, then we call the function Libusb close to close this device. Based on the document, when the handling a Libusb Hotplug event device left, the only safe function is Libusb get device descriptor. So on the detach callback function, we can call this function get a device descriptor and then print out information which device has been detached. Back to our editor. First, we declare a device descriptor named DESC. First parameter is the device. Second parameter is the pointer of descriptor. First, vendor ID. Second is the production ID, so we know which device has been detached. Else, we just print out error message. Next step, if a USB device is open, then we close. Then we return from this function. Function print USB info is being called from the Hotplug callback attach function and pass the parameter device. This function print parameter and the information of this device. First, get device descriptor. In order to convert code to the description, we create a simple class Libusb DESC class. We name it DESC object. Declare a descriptor. Libusb device descriptor DESC. Using function Libusb get device descriptor. First parameter is device DEV. Second parameter is pointer of DESC. If not success, we just print out the error message, then return. After we get a device descriptor, we're going to print device descriptor level information. First, print out vendor ID and the production ID. And the descriptor type description using our convert object. DSC descriptor type and the number of configurations. Next line, we're going to print out class description, USB description, and the speed descriptions. Device class code and the subclass. BCD USB type and the speed. Next step, check Open USB device accessibility using Libusb open or Libusb close. If a handle is not none, it means Libusb is open. Using Libusb open, first parameter is the device, DUA. Second parameter is the handle. If not success, we just print out the error message. Then return, otherwise print out. Libusb open success, it means device is accessible. Next, we're going to get and display device current configuration level parameters. First, declare a configuration descriptor variable. Name conf DSC, and we're using the function Libusb get active configure descriptor to get the configure descriptor. Function Libusb get active configure descriptor get the USB configuration descriptor for the currently active configurations. This function takes two parameters. First is the device. Second is Libusb configure descriptor array, and this function returns 0 on success. The error code get the errors. Back to our editor. First parameter is the device, DUA. Second parameter, configure descriptor. If not success, print out the message failed to get current configuration descriptor and return. On success, print out configuration level parameters. Libusb configure descriptor has the following fields: the length, descriptor type, number of interfaces, and interface arrays. In our demo, we just print out descriptor type description and the number of interface. Back to our editor. Descriptor descriptions from the configuration descriptor type and the number of interfaces. Libusb configure descriptor field interfaces. This field is the array of interface supported by this configuration. The length of this array is determined by the field number of interfaces. So one configuration can have multiple interfaces. Next, we're going to make a loop, get a configuration interface, and display interface level parameters. For and I list the number of interfaces. For each interface, from the interface I, we're going to print out the number of outer setting, which is the interface descriptors. First is I, second is one interface could have a multi number of outer setting, which is interface descriptors. So next we're going to make loop to get the device interface outer setting level parameter. First, get the descriptor. And print out number of endpoint of this interface descriptor. First is the J, number of outer setting, which interface descriptor, descriptor type, interface class, interface subclass, and the number of interpoints. Since each interface descriptor could have multiple endpoints, we make a third loop to get and print out device interface outer setting endpoint parameters. For each endpoint key, we declare the variable endpoint and print out endpoint attribute, endpoint address, key, descriptor type, convert from descriptive type, and the point transfer type, and porter address. Libusb endpoint descriptor field BM attribute is the attribute which applies to endpoint when it is configured using the B configuration values. Bit 01 determine the transfer type and corresponding to the Libusb endpoint transfer type. In this demo, we just pick up the bit 01 endpoint transfer type. Back to our editor, when we print out the transfer type, we're using the endpoint attribute and with 0x03, so we only pick up the bit 0 and 1. Finish loop, print interface level, outer setting level, and endpoint level parameter. We're going to release the configuration descriptor using Libusb free configuration descriptor. And release interface using Libusb release interface. Since one configuration could have multiple interface, so we make a for loop. First parameter is the handle. Second parameter is the index, which is I. Now we finish write program. Save. Now we're going to compile our program. Program has been compiled. This is our executable. Now we run our program. First, check platform Hotplug support is available and register event attach callback and event detach callback. Now start listening Hotplug USB device to be attached or detached. To test, we're using flash drive to attach to USB port. Now flash drive has been attached. Oh, we got error, no access to device. It's insufficient permission. Now we detach and the program detached. Then we log into super user and run our program again. We started listening Hotplug USB device to be attached. Touch our flash driver again. Now we get attached. Now we get access. First we print VID and PID device descriptor. Number of configuration is 1 and it's USB 2.0. High speed for 80 megabit per second, and the lab USB open success means accessible. Configuration have one interface and the interface array 0. Number of out setting is 1. Out setting 0. Interface descriptor is mass storage and the subclass is image device. Number of endpoint is 2. Endpoint 0 is a bug endpoint. Address is 129. Endpoint 1, which is the second endpoint, is a bug endpoint. Address is 2. For each endpoint, the attribute and the endpoint address are very important parameter will decide which kind of transfer you're going to be used between USB devices and systems. Lab USB has support following transfer type: controlled transfer, isochronous transfer, bug transfer, interrupt transfer, and bug stream transfers. Based on our device type, using bug transfer between system and USB devices. In this short video, we're not going to that far, and we just unplug device has been attached. Second example, we're going to attach a USB 3.0 flash driver to the system, restart our program again, and starting listening Hotplug USB devices. Now we are going to plug in USB 3.0 flash drive. USB device has been attached. VID 04E8, PID is 8001. This device has one configuration. It's USB 3.0, super speed 5 Gbit per second. Lab USB open success is accessible. For this configuration, we have one interface, and for the interface 0, we have two auto setting. Auto setting 0, it's a mass storage device, image device subclass, have two endpoint. Endpoint 0, address 129, endpoint 1, the address is 2. Auto setting 1 is the second interface descriptor. It's a mass storage, image device subclass, has 4 endpoint. Endpoint 0, address 129, endpoint 1, address is 2, endpoint 2, address 131, and point 3, address is 4. Now we detach device unplugged. So we got a device has been detached. VID 04E8, PID 8001. Hello, thanks for watching my video. Wish it is useful, and it's going to be great to have your feedback.